Welcome back, YouTube. So we're in part 3B, I guess now. I don't know what happened, and YouTube was a bear trying to let me get back on. Okay, so let's just continue on from where we were, and these are going to have to live into perpetuity as two separate videos. I might merge them. Let's see. Somebody asked a question about the SHSAT 9. Let me toss that in before we get into this, I guess, so that conversation is done with, I guess. Let me see if I have a thing here. Right. So somebody asked about the SHSAT 9 topics just before we got flipped off, and so let me go into that. So if you go to that SHSAT facts again, I keep referring to some of the same stuff. See this line here from my main webpage, GregsTutoringNYC.com. Click on that. It's going to bring this up with a whole bunch of goodies. Some of the goodies is going to be math topics. I have a PDF, which is this right here, and a video talking about the topics as well, which is popping up to the left of it right now. So I will explore some of the SHSAT 8 math topics and some of the SHSAT 9 math topics in those. And that I believe was the question. Maybe it wasn't, but I believe it was. Okay, so with that note, let's pop back in here. Let me just make sure this stream is going well. That's why I'm always checking this. YouTube is not always helpful. Let me see if we're getting into here. Let's see, that says 3, so that's not it. Where's the current stream? Let me get out of here then. That's not it. Okay, that one says live. It should say 3B though. Wait, is this where I'm at? Whoa. Let's see if we can break a record here. No, that's the original one, the other one. Wait a second. So I want to see if we get questions or whatever too. That's why I always want to see if I'm just talking into the void or not. 3B, here we go. Okay. All right, so let's get back to the problem at hand. Whoops, let me turn down the volume of this thing. No, that's the original. And hopefully we are all set. This happens every so often, just as your phones and your computers and the internet and your router and your modem and your the list goes on. So I mostly only do live streams, so that's where we're at here. Okay, so we were at this 24/64 was the last thing we ended up with, and I noticed that 8 goes into both of those. So we end up with 3/8 pi. Okay, so from this point, we have two paths to take. One is we can convert the 3/8 into 0.375, and all of you should know that. Or leave it as 3/8 and multiply that by pi. Either way, in other words, we're going to do 0.375 times 3.14, or we're going to do 3.14 times the 3 and then divide it by the 8. They both seem a little brutal, so let's go down here and maybe do some of that. I'm not sure. So in other words, and if you don't know what 3/8 is, you take 8 and you divide it into 3, right? So 8 goes into 3, it doesn't. We get a 0, bring up the dot. 8 goes into 30 3 times, because 4 times is 24, and the other is 32. So we get 6 left over, right? 8 times 7 is 56, right? With 4 left over, and 8 into 40 is 5 times. So we get that 3.375 for the 3/8. But you should know it, and that way you can save time. Anyway, you have 0.375 times 3.14. How many digits do we know to use? We kind of really don't. I'm kind of just going by this nearest hundredth. And if we use precision, this is already 3-digit precision. So that's 2. So I think that's sufficient for what we need to do. So we need to do this nasty multiplication now. 5 times 4 is 20, 0. Bring up my 2, 28, 29, 30, 0. Bring up my 3, 12, 13, 14, 15. And then we just copy 5, 7, 3. And then we have to do the 3 now. 5 times 3 is 15. Carry my 1. 3 times that is 21, 2. Carry my 2. And 3 times 3 is 9, which gives me 10. This is why I didn't want to necessarily do this live. Did I just make a mistake there? Yeah, that was a carry of 2, not 1. So that's 9, that's 11 here. Okay, if we add that up, we get 0, 5, 10, 5, 1, 6, 7, 8. We get 1, 1, 3, 4, 3, 4, 5, 6. No, that was a 7. Okay, so we're going to have to now move the decimal to the right place. So we have 1, 2, 3, and then 4, 5. So we have to do 1, 2, 3, 4, 5. So that means we get 1.1 7550. And the answer should have been I think there's another 7 here instead. That was supposed to be a 7. And then you round it to the nearest hundredth. No matter how you slice it, you're going to get 1.18. Okay. There is an error in the handbook about this. I believe the actual number was supposed to be 1.17775 or something like that. And the handbook has 1.1775 or something like that. It's missing a 7 when it actually gives the answer. The round happens to 1.18 anyway. So you'll be good with that. Okay. All right, so that's how you do that one. By the way, the double check. Oh, actually, we could have. So the double check of the 0.375 times the 3.14 is to actually flip them. Do 3.14 times 0.375 and see if you get the same answer. If you do, most likely you did the double-digit multiplication right. The other choice again was because it was 3/8 pi. We could have done 3 times 3.14 and divided that by 8. Okay, and we're supposed to get the same number over here. And then again round it. Okay. All right. So that's that one. Okay, 59 has no illustration. A homeowner has a budget of $135 for the installation of a light fixture. An electrician charges $60. So the max is $135. Somebody's charging $60 per hour plus a one-time of 45. So that, just by looking at it, looks like a y equals mx plus b. That's a linear equation. Okay, where b is the flat fee offset, so that's 45. Okay, and if it's $60 per hour, basically we're talking about 60 times x. In this case, do they say what we need to use? No, so I'm just going to put hour, and then the total cost is going to be equal to that. All right, so that's where we're shooting for here. And then they say the homeowner has a budget of 135. So basically what we're really saying is it's $60 times the number of hours plus the base fee of $45, right? That has to be less than or equal to the $135. Okay. Let me just double check that YouTubers are right. I see a few people in the lobby. Welcome. Hello. Please like and subscribe and ask any questions that you guys have. I'm going to be going for about another half an hour. I have a session at 4, so I want to basically be ended by 3:45. So anyway, if you have questions about the problem I'm doing, ask them please while we're doing it. This way we can be live and interactive. If you have a general question, put it out there anyway, and I will get to it either after a question or at the very end. Again, please like and subscribe. All right, so that's what we're trying to solve. So we just do it as normal. We can subtract 45 here, then we subtract 45 there. All right, we get that cancels out. So we get 60H is equal to, what is that, 90? Okay, we need to get H by itself. So we're going to divide both sides by 60. And that's obviously 1.5. Okay, we can plug it back in. If the number of hours is 1.5 and it says it's a decimal, and we have to grid this in as well, so it all kind of jives. The home has a budget of $355 to $60 an hour. So $60 an hour, if we try to reverse that back out, right, 60, it's going to be $60 for the first hour and plus 30 for the half hour. So that's 90, right? And then there's the one-time fee of 45 all the time. So that gives us the 135 back. So we're feeding it back into the question to make sense out of it. And that works. So the most number of hours within that budget is an hour and a half. Of course, if somebody can get the job done faster, more the better, at least for the homeowner. I guess the electrician wants to charge more than that, but that's basically the thing. It was not important that you know that this is based on a linear equation. However, that underlying concept can be handy to know when you're trying to figure out these things, because it's modeling something that we're going to be able to get used to. Um, all right, so those of you in algebra and so on probably have had this already. Some of you may not be having it, and some of your teachers might be covering it right now even, or are going to cover it even in the next week before the exam. So that's the deal with that kind of stuff like that. All right, anybody have any questions about that? This is a pretty classic SAT question, and just a standard basic algebra question, if you will, where it's just modeling the linear equation. There's some constant multiple going on, and there's an offset to it. All right. By the way, a lot of you should be aware that the constant of proportionality was there was a lot of questions about it last year, and there's a few in the current handbook as well, which we're going to end up going over. This is not a constant of proportionality, but mx, the m in mx is the slope, and that is a constant. So, but it is not a linear equation. Is not the constant of proportionality. Um, when we talk about the constant of proportionality, we're talking about y equals kx, where we're talking about k. Here, this is kind of based off of it, but it's a slightly different concept. So there is no constant of proportionality here in specific because of the offset, that $45. That's throwing it off. There is not a proportional relationship going on between the number of hours and the total cost, because no matter what the number of hours is, we have to add 45 onto it. All right. So because this is modeled on a linear equation, if we were to graph it, it would be a line, but that doesn't make it constant. All right, it's constant once it's offset, right? And by the way, kind of a heads up, which is one of the ways to solve some of these, is that if it is the constant of proportionality question, it will go through 0, 0, right? X will be 0 and Y will be 0. If that's true, then it can work. And we can show in this example, even though this was not a constant of proportionality question, that doesn't work. Because if we had this here, um, the total cost equals $60 an hour plus the 45. Well, if the number of hours was 0 and the total cost was 0, what happens to the 45? It doesn't make sense. 0 plus 45 is 45, not 0. So that's how we're proving there is no constant of proportionality in this scenario, right? The constant of proportionality is dealing with the y equals kx only, where if you will, the the plus b is plus 0. So it means there's no offset. There's a line and it's just there. It goes through the center, right? So if we had this here, it might be something like that where it goes literally through there. But in our case, it's up 45. So in our case, it might be going like that, at least for this question here. All right. So that's kind of some of the details and kind of a heads up. There's wild cards and SKUs to each exam on test day, plus across all of them as well. And each year has its own kind of little theme and stuff. Um, but the heads up that I'm trying to communicate to you guys from the handbook is that there's enough constant and proportionality questions on the exam that that's something you guys should, if you don't know it, you should. It was the focus of grade 7 math, all right? But interesting, the newly tested topics. Yeah, and it is and it isn't. Um, the thing is, uh, constant and proportionality was always game for the test. I always taught my students constant and proportionality. It's just that it didn't come up often, and I think that's a good way to do the testing because then you guys are left being on your toes, always alert about it. Okay. Um, Probability tree, yes. If you look in the errata, that question number 99, I think it was, um, has a new style question. Again, look at my unboxing video. Anybody who is interested in uh, what I feel is going to be on this year's exam, there's kind of some hints in it. I believe they're not guaranteed; they're just hints. Um, Constant proportionality, which has been done before, but check this out. Did you ever review the 2017 state document? I'm not sure what you mean by that. You're talking about indicates the material is covered on this SHSAT. You're talking about the New York State exams, the New York State tests. Yes, I believe I reviewed that one. Um, Certainly the multiple choice sections I have. I have another series called Hardest Math. If you go to GregsTutoringNYC.com/hardest dash math, you'll see my coverage of those examples on there. And there. It indicates slice of 3D shapes. I'm not sure. It's the doc that indicates what material is covered on the SHSAT. There is no document. It's the New York State curriculum overview is what it is. But anyway, constant proportionality is a huge part of grade 7, so it's definitely in there. Right, it's official. That's why everybody, probably one of my top questions everybody asks me is what are the topics on the SHSAT? They're everything you've learned so far. They're everything in the curriculum. The problem is some schools skip the curriculum. Um, So it depends on your middle school, depends on what you're in the honors class. It depends on a lot of things. At the end of the day, the SAT says it's the grade 7 standard, the grade 8 standard for ELA and math, and that's what we need to use here. It doesn't mean it's going to ask you about all of them. So that's the wild card I keep talking about. And it's not that they might even just give you one question; they might give you 5 of them. So that's part of the heads up that I was trying to communicate here. The handbook, is it the actual exam given to students? No, it's not. It's only practice. They, DOE never releases the actual exams. It's not a jumble either. It's just questions that are very similar. Okay, let's do question number 60. That was just a sidebar, really, to talk about the constant proportionality, just because I saw the linear equation. Anyway, the point of that whole thing was that linear equations are not constants of proportionality equations. So we have 60 shows us an illustration. To me, this is an illustration with a list of numbers. They seem to be random. They seem to be degrees Fahrenheit in particular. They're not ordered, but they're scattered. They're all integers, positive and negative integers. So let's use that to see what's going on here. You have to teach, that's why I'm raising it. And again, if you guys look at the unboxing video, that's really a big part of what my unboxing video was about. That there's going to be wildcards, and you guys need to deal with them on test day no matter what. You have no choice if it's a question, and you need to pull stuff out of your hat that you know about. So that's why, as I keep mentioning in many of these videos, the New York State math test is really testing your memorization and knowledge base, if you will. The SAT is taking those as well, you still need to know those, and bumping it up a level into creative and nuanced situations. All right, the list shows that the daily low temperature in the city during 6 days in the winter. Okay, what is the difference between the lowest and the highest temperatures in degrees Fahrenheit? So first of all, is there a unit conversion? That's in Fahrenheit, that's in Fahrenheit, 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 Fahrenheit. And then it wants the lowest and the highest. So we could reorder this, or I could just note that 7 is the highest and -5 is the lowest, right? Let me just double check that. By the way, I have slight dyslexia on top of this, guys. So, it's a chore to look at numbers for me. And that's important, though, because it forces you to get a focus on attention to detail. And in the event, 7 is definitely the highest and -5 is the lowest. And then it says, what's the difference? Difference is code for subtract. In fact, this whole thing here is code for range. When we talk about points of center, we have median, average, mode, min, max. One is range, which is the subtraction of the high minus the low. All right. So at this point, we're going to have 7 minus -5. A minus of a minus is plus. So we get 7 plus 5. And then we get 12. Okay. All right. Some kids will do this backwards, or they'll just get this completely wrong. They'll end up with a 2 here, or a -2, or they're gonna do. They might even do a -5 -7, or -5 plus 7, whatever. The answer is the positive one here. That's what they're looking for. There's no gotcha. There's no two answers here, right? All right, so the answer is 12. They're just looking for the range. That's once you realize the coded word is there, and the range is the difference between the highest from the lowest, even though they wrote it as the lowest and the highest. All right, so that's what we want. We're talking about basically the absolute value difference, the magnitude, right? Normally we talk about a distance or something like that. We don't necessarily talk in negative values. So the first general one thing is that, okay? Okay, 61 is a busy question as well. 62, the last one, yeah. I'm gonna do 62 first because I want to use that space, and then I might use the extra space that I didn't use for 62. So I don't like 62. Let me make this larger. So first of all, there's an illustration here, which is this is the box plots. So this is the second one, or also called the box and whiskers plots. Okay, so box plots also appeared on the exam last year and threw a lot of kids off. But again, this is one of those topics where even from grade 5, many of you should know this. Unfortunately, some middle schools don't teach this. As well, this is usually a topic that your teachers throw at the end of June and the last few days of class. Okay, so this is going to be a topic. This is another heads up. Let's put a face there for a heads up, right? Be alert, big eyes, okay? Watch out for this. So if you don't know what a box plot is, go look it up. If you think you know what a box plot is, go look it up, okay? And run through a bunch of examples. Go to cons or whatever, and run through a bunch of examples about them. There's a whole bunch of different parts of this, okay? All right? This is normally the min. That's the minimum number. This is the maximum number. Okay. This center part here is called the IQR, interquartile range. It also has a min and a max. So this is the min of that range, and this is the max of that range. Okay. And this right here is the median of the whole set. Okay, I'm just summarizing this. I'm not trying to teach this to you guys. You're supposed to know this already. Okay, if you don't, this is the go through. If you're still confused after looking it up and going to cons and looking through some of your workbooks, a lot of workbooks explain this as well. Please email me and we can arrange for somehow I can get this to you. I'm just doing a quickie overview here. This is also known as Q0, Q1, Q2, Q3, and Q4. All right, so that's basically what's going on here. So there's two levels of problems with this question. There's three actually. First of all, it's a grid in. The second is if you don't know these, you can't answer it. All right, and there's a third whammy, which is that if you look at how they did this, and I point this out on my unboxing video as well, if you drop this down here, it's not clear exactly what value that is. The same for this here. If you drop this down here, it's not clear what value that is either. Okay, this one here, the second one I did is closer. That does seem to be 78. But remember, they told us that things were not to scale unless they told us what they were. And I said there was a nuance to that, which was the coordinate geometry, right? They said charts. And then I said there was a tenet to that, which is the number lines. Okay. All right. And this one here is kind of the gotcha because where exactly is this point right here? Okay. The midpoint, that seems to be 38. So this seems to be 39. So that's the gotcha with this, that you don't quite know what those two values are. All right. So now that we kind of ripped the illustration apart for a bit, let's go into the question. The box plot shows the average monthly high temperatures in New York City for 12 months. So for 1 year. What is the difference between the range and the interquartile range? All right. So if we look at what the numbers were, the range is the same as the min. No, sorry, the max minus the min. Okay. So the max was this here, which is 84. The min is this number over here. So that's the one we don't know the exact number on. It seems to be 39. All right. And then it says in the interquartile range, the interquartile is from here to here. So that seems to be 78 minus 48 is equal to 30, right? And then this one here, if I did that right, that's 40, that should be 45. Okay. Let me just make sure that was right. Uh, let's see, we have 78 minus 48 is 30, and we have 84 minus 38, 39. Okay, that's going to be 45. So then now what they're asking us is what's the difference between the range, which is the 45, and the interquartile range was 30. So again, it's difference again, so it's subtraction. So it'd be 45 minus 30 is 15. Okay, and then the only question we have left is the one over here, which is nasty in its own right. Yes, all number lines are drawn to scale. That's what I said. A grocery store sells 1 gallon containers of milk for $3.99. The store also sells orange juice in packs, 6 packs of 6, 5.5 fluid ounce bottles for $1.79. So we have 1 gallon is $3.99, and then there's the second sale, which is a 6 pack of 5.5 ounces for $1.79. Okay, so we're up to here at this point. Okay, so that's our groups there. We can so this requires a unit conversion now. So a lot of you forget that. To the nearest dollar, how much more would a gallon of orange juice cost than a gallon of milk? So we need to do that unit conversion. Let's get some space here. So a gallon is what? So we need to convert a gallon into ounces to be able to do this conversion here, to be able to get into the total number of ounces, all right? So a gallon, we have 4 quarts is 1 gallon. So that cancels. So now we have to convert quarts into the same thing, right? So 2 pints is 1 quart. So the Q's cancel out and we're left with pints, right? And then we have 2 cups is a pint, right? Now we're left with cups, and then one cup is 8 ounces, all right? So cups cancel out. So all we're left with on the top, we're going to get the 4 times 2 times 2 times 8. So we get 16, 32, 64. We get 128 ounces. All right. So 1 gallon is the same as 128 ounces. All right. And at this point, we have to also convert this into the number of ounces. So we have 5.5 times 6. 6 times 5 is 30, 0, 3, right? 6 times 5 is 30. We got 33. So what we basically have is 33 ounces is to $1.79, right? As 128 ounces is to we don't know how much. All right, so that's the conversion we need to figure out to do. And we set up a proportion with that. And that just becomes a nasty division at that point. All right, so we basically have 33x equals the 1.79 times the 128. And then we're going to divide both sides by 33. And then that's just down to a nasty multiplication and division and stuff at that point. So when you do that multiplication over here, yeah, I did that offline. That's 229.12 over 33. Okay, and that gives you 6.943. Okay, which is the same as 6.94 basically. And then we have to take the 6.94 and subtract it from the original price that we had it, because that's what they want to know. How much more would it cost if it was the same price as the other thing? All right. So 694 minus the 399. Okay. And when we do that, we get $2.95. Okay. What they asked us though was to the nearest dollar. So then the answer would be $3 at that point. Right. So what we had to do was figure out how many ounces we had here at this price. Then we had to take how many ounces we had in the gallons and figure out the price it would be as if it was the orange juice. All right. And then take that price prorated, the unit price, if you will, and go backwards. And then work it out based off the $3.99, and that gets us there. All right. I think that's the grid in section here. And then I might do the grid in for Form B next, or just start on the other problems here as well for the next section. In other words, the multiple choice ones. All right, guys. Peace and have a good day. I don't know if I'm going to get to do another stream here or not. And I just noticed that I never brought this back. So I may have to redo those problems anyway. All right, when I flip back from the page, so that's on the last one, that's the work. So let me just change the color of the pen real quickly then and go through it, since we didn't do that, never showed on the screen. So this was our conversion from gallons to quarts. That's 4 quarts over 1 gallon. Then pints to quarts, or quarts to pints, so it's 2 pints over 1 quart. Then the next was 2 quarts over 1 pint, which is converting it, cups, and then converting it to ounces. So we got the total number of ounces. At that point, we set up a proportion. The 33 comes from the 5.5 times the 6 at the price they gave us. And then now that we know the total number of ounces of the milk, we're going to apply it. Then when we get that answer finally over here, right, I'll increase this slightly. And then we actually do the subtraction. We get the 2.95, and they're asking for the nearest whole number. All right. All right. So we ran into a whole bunch of technical issues. The other stream got killed, and this one I didn't put the page up on it. All right. That's the nature of this. I might redo this question. You can certainly email me to get an understanding of it. All right.